Let's take a look at Neverthrow versus Effect.ts. A lot of people conflate the two. They'll say Neverthrow is better because it's simpler, easier to pick up, and doesn't come with the same learning curve. But the truth is they are fundamentally different tools. Neverthrow's whole premise is about treating errors as values, and Effect does that too. But that is not the main thing Effect brings to the table. If you think Effect is basically Neverthrow plus some extra stuff, you're missing the point entirely. So in that sense, it's not really fair to compare the two. They're solving different problems at different levels of abstraction. But just to do the exercise, I put together 4 small problems. And for each one, I'll show you the Neverthrow version and the Effect version side by side. Not because one is always better than the other, but because I think it's a really good way to understand where they overlap, where they do not, and what Effect is actually giving you once the problem goes beyond just error handling. So let's start with a simple one, and that is parsing a CSV. So reading a local file, validating the rows, etc. Very simple stuff. So we have our type user, then we have some possible errors. So an error reading the file, an error parsing the CSV, a validation error, or a write index error. We then have this fake parse CSV function, and so we declare this validate row, and we simply check that each property that we're looking for exists. We're not doing this extensive check that they are the correct type and whatnot, but for demo purposes this should suffice. And then we have our import users function. So we take in the path and then we use save try, and here we have our generator, and we can say text is equal to yield, then result async from promise. Then we use the file system read file function, and then if we get an error, so unknown of course, we remap it over to a read file error. Then we extract the rows, and if there is an error parsing the CSV, then we return this typed error as well, preserving the original cause. And then here for users, we combine all results into one. So as we can see, we get, in this case, an array of users, since the yield will short circuit if there is an error and unwrap the success value if not. So that's why we get an array of users here, and we simply validate each row. And then we write to the file. So we use from promise, and again, we remap the error into something more meaningful. And finally, we return OK undefined, so void. And what we get back is a function that returns a result async that succeeds with undefined and fails with import error. So far so good. Let's now take a look at the Effect version. So for this, since we're using Effect, we get schema, so the runtime validator. So there's no need to bring over another library like SOD. We have schemas for free, and here we define the same thing: ID, email, and name. And then we attach some static properties. So an array is just schema.array for user, then JSON, same thing. In this case, when you're parsing an object, it is going to take in a string, and it is going to parse it using json.parse, and then it is going to validate it against this entity right here. So no need for doing json.parse, or bidirectionally json.stringify. And in Effect, we call that encoding and decoding. So when we're encoding, we're going to stringify it as JSON, and if we're decoding, so parsing, we're going to json.parse it, and then obviously use this schema right here to validate the actual data. And then we have decode array, which is just parse on unknown effect and using the array one. And we have the encode JSON, which is what I talked about, where the input is a decoded array of users, and it will give us back this stringified JSON. And if there's a serialization error, then we get this schema error in the error channel. Next, we can define our possible errors using schema. So we can say schema tagged error class, and this is our discriminator. So this is the tag, and then same thing, we preserve the cause. Then we have our fake parse CSV, and then we have our import users. So same thing, a generator, but this time we yield this right here. What is this? Well, this is a service for the file system. So Effect has dependency injection built in as opposed to Neverthrow. So here we're yielding a service that must be satisfied, so must be provided to the program. So if we take a look at what this returns an effect that succeeds with void, fails with all of these errors right here, and requires a file system implementation. Anyway, using this file system service, we can say read file string, and then we can remap the error. So notice how this in itself is more declarative. Then for the rows, we can say effect.try, and then we try parsing the text, and if there's an error, we fail with parse CSV error. Then for the users, we say yield user.decode array rows. So this is runtime safe as opposed to the Neverthrow version. And then we encode it, so we get back the JSON, which is a string, and if there is an error, we simply remap it over to write index error. And then we write to the file and we pass in the JSON, and same thing, we remap the error. And now here, notice how we say effect.provide node file system.layer. So this right here, as the name suggests, provides the live implementation if you're running it with the node runtime, but it could be the bond runtime, or you could even provide a test implementation, whatever you want, as long as it satisfies the shape of this file system service. And as we can see, main will not require anything. So what we can see, and let me split this, they are very similar in practice. Effect is a little bit less verbose since it integrates everything with dependency injection, with schemas. Neverthrow is clearly more imperative in that way, but if you just focus on the error handling part, they can achieve pretty much the same thing. But as you can see, just by using Effect, you get access to more tools. But this is just scratching the surface of Effect. So let's now move on to the next example. So now here, what we want to do is make the import job real. So we want to process a large CSV with bounded concurrency, update progress as rows finish, and keep the result shape around the actual work. So now here we're going to add telemetry using the OpenTelemetry standard. Now this file is a bit bigger, so I'll not zoom in into everything, but we have a couple of utilities for the errors. And here I created this with span helper. So it takes in the name of the span, the attributes of the span, and then the result, which is a result async. And it is going to do everything for us. So it is going to get the tracer, start the active span, and well, record the different exceptions, timings, etc. Then we have the same validate row, but here we have these new validate rows, and it is going to manage the concurrency for us. So I'll not zoom in into the actual implementation details, but as we can see, it is not trivial at all. We have to handle every single case. And with this, we can now define our import users, we start the span, we wrap all of our operations with span, and then here for users we simply say validate rows, and again this will handle the concurrency for us. And then we do another with span for writing to the file, and then we need to handle the exceptions and record them to the span, and that's it. So as we can see, 300 lines of code. And this code right here is trivial in that you will most definitely need to handle concurrency in your applications. Let's take a look at Effect. Now for Effect, it is virtually the same thing as the first solution in that we have the same schema classes for the errors, the entity, and for import users, all we need to do is say with span, and that's it. It will handle absolutely everything for us. And for concurrency, all we need to say is for each, and then we pass in the rows, then for each row we decode it, and then we set the concurrency to 32. Now just one thing to note from these examples is that this concurrency is pretty much useless because the coding doesn't create a suspension point. It will not yield to the event loop. So everything in fact will run sequentially. But let's just imagine that this decode will call an API or whatever. In that case, we will obviously leverage from concurrency. Anywho, we can then do a with span for this. So it will handle the parent to child relationship for us. And then here for JSON, we encode the users, same thing as before, and we write to the file. And then for this whole computation, we can attach this parent span, which is import users. And that's it. Everything is still the same. And lastly, in Effect, to actually feed those traces into a service, we need to provide the layer. So here we can say node SDK.layer. We define our resource and then the span processor. And that's it. All we need to do is say Effect provide and then OpenTelemetry live, and we're good to go. So notice how we were able to achieve the same thing with just 95 lines of code. Let's now move on to the third example, and for this one we need to write through a temporary file and guarantee cleanup on failure. So same thing as before, I've removed concurrency for this example just so we keep this focused, and notice how we have to deal with the temporary logic imperatively. We need to do the try catch blocks, and then the finally, of course, that will remove the temporary file. So here we would need to say yield new result async and then write temp index and for the users. How does that look like in Effect? Well, for that we can use scopes. So in Effect, a scope is just for managing resources. So a computation can require a scope, and so you can attach finalizers to that scope. And once the scope closes, it will run those finalizers. So in our case, what we can do is say yield effect acquire release. And then we make the temporary directory, which is going to give us back the directory. And then here we can specify a callback. So the finalizer, where we say file system remove directory, and that's it. And this right here, this acquire release, will require in the requirements channel a scope. So now we need to provide the scope. So for that we can say effect.scoped. So once this computation is done, regardless of the outcome, it will close the scope where it will run the finalizers, and that's it. Now I was going to show a fourth example, but I think that this is enough. So as we can see Neverthrow is good for the error handling part, just like Effect is great at the error handling part, but Effect offers way more. And in my opinion, if you are already integrating Neverthrow, you might as well integrate Effect. Why? Because Effect focuses on pragmatism. Everything in Effect has a purpose, a practical use case. It is not a functional programming library focused on theory. It is not academic. It offers dependency injection, retries, scopes for resource management, and a huge ecosystem for writing backends, for working with WebSockets, with web workers, with AI. Even for the frontend, you have Effect Atom for global state management. And especially in the world of agentic coding, there's no excuse to not use a library like this, when the reality is no one is writing code by hand anymore. All you need to do is clone Effect locally and then point the AI to that repository, and then it can look for everything that it needs. Anyway, I hope this video cleared things up, and if you want to learn all about Effect, make sure to check out my course Practical Effect. We'll go over the very fundamentals, building the mental model, understanding the effect type, understanding fibers, error handling, schema, resource management and scopes, so on and so forth, all the way to building an HTTP server using Node's low-level APIs, driven all by Effect's framework, so handling request lifecycles, fibers, interruptibility, etc. Link is in the description. Anyway, that's it for this video. I'll see you in the next one. See ya.